So on that first video, I went ahead and reviewed last year's factoring techniques. Now we're going to talk about what's called quadratic forms. Quadratic forms looks very similar to last year's technique. You'll notice there's 3 terms on both of these. And then the other thing you'll notice is that the exponent right here, the biggest exponent, is twice as big as the middle exponent, just like in a normal quadratic. So if I go back to one of our quadratics, 2 is twice as big as the exponent of 1 right there. So if you get a relationship like that, you'll notice this one has a 4 and a 2, so 4 is twice as big as that exponent of 2. If you get that it's twice as big, you can actually do the same technique that you learned last year. So once again, you find your factors of 3, which would just be 3 and 1. Find your factors of 2, which is just 1 and 2. And then you just have to figure out how to pair them so that they subtract to give you a positive 1. Okay, so 1 and 1 will give you 1, 3 and 2 would give you 6. 6 and 1 will not subtract to give me 1, so that means I've just reversed that order. So I'm going to put 2 and 1. So 1 with the 2, 3 with the 1. 1 times 2 is 2. 3 times 1 is 3. And we want to subtract to get positive 1, so that means one of them negative, right? So 3 minus 2 gives you positive 1, which means this one right here would be negative. So we just need to figure out how to place these numbers, and it's going to be the same thing as what you did on the other problems, except that we have to pay attention to what our exponent was before. So if it was x to the 8th originally, we're going to do an x to the 4th because we're just going to split it in half. So I have 3x to the 4th and then a 1x, or just x to the 4th. So you split whatever it is in half. Then you place the numbers just like you did before. So 3 is paired with the 1. So the 1 should go, and it's a positive 1, should go in the other parenthesis. The negative 2 is paired with the 3, or sorry, with the 1. The 1 times negative 2, so those should be multiplied, while the 3 and the 1 should be multiplied. And we have that. The only last step you have to do with quadratic forms is you always have to double check to see if you can factor more. Now, when we've seen 2 terms, the only factoring technique I've taught you so far today is the difference of perfect squares. But you'll notice that 3 and 2 are not perfect squares, so these do not, in fact, factor any further. So, well, at least the first one doesn't. 1's a perfect square, but because this is a plus sign, it's a sum of perfect squares, not difference. That means this one would also not factor. So both of these are done factoring. You don't have to do it anymore, but sometimes they will go down further. So let's see if this one is an example of that. So same technique. So we've got 5 and 1. Let's do 6 and 2. That won't work. I'm going to try to go a little faster through this. So let's try 3 and 4. So 5 times 4 is 20. 1 times 3 is 3. Now, we are adding the numbers according to the last sign. So this last sign tells you what you're doing to the numbers. But we want to get 2 negative, or add 2 numbers to get negative. So both of the signs need to be negative. And that does add up to negative 23. So once again, we've got 5, and then you're going to put x squared because we're doing half of the exponent, of the highest exponent. Then we've got x squared. The 5 was paired with the 4, so this should go in opposite parentheses, so minus 4. And then the negative 3 goes in the other. Now, we've only learned difference of perfect squares again, so 5 and 3 are not perfect squares, but x squared minus 4 is, so that one can factor down further. So we've got 5x squared minus 3. X squared minus 4 is the same as x minus 2. X plus 2, as we learned earlier. And we're done. Oh, and that's a new method. So that is that method in a nutshell. I'll do another video for the other method.